in the denominator? How many factors we have in the denominator? How many factors we have in the numerator? So 2 of the ending logs, simplified logs, will have, and how many will have negative? Okay. Good. So we start with the quotient rule. We have to. We have no choice. Can anyone dictate? Natural log of x to the 4th times the square root of x squared plus 3. And then, yes, natural log x plus 3 to the, well done. Careful now. There is a product in here. We apply the product rule. So then, natural log of
X to the first plus
excellent. Yes. And I can write here minus 5 natural log of x plus 3. Let me caution you, do not be tempted to try to simplify this. We have no rule of log applied to a sum. That's carved in stone. No one can touch this. We only have 3 rules. Log applied to a product, log applied to a ratio, and log applied to a power. Do not attempt to simplify this and say it's natural log x plus natural log 3. It's not. Perfect. So now, what power is the square root? Well, you know the square root is a power. Which power? 1/2. It cannot be 2. Very good. And this is fully expanded. We cannot apply any more rules. We applied all 3. We applied the quotient rule, we applied the power rule, we applied the product rule. That's it. There's nothing else. Do not touch this. Do not touch this. They cannot be further simplified. Do you think we need more condensing? If you say yes, we're going to show another problem. If you say go back now to condensing, we're going to start condensing, going backwards. What does that mean? We are given this now, and we are asked to come up with this. So would you like more expanding, or can we start condensing? Condensing? Yes? Okay, condensing then. Okay, we start with a simple one. 47. Log. I don't see the base. What is the base if I don't see a base? Very good. It is base 10. Okay, so this time we have 2 logs, and we are asked to come up with 1 log with coefficient of 1 in front of it. So what do? I see that there is a difference of logs. If it's a difference of logs, be careful. This will not change into log over log. It will change into log applied to a ratio. Very careful. So do not confuse, I can't stress enough, do not confuse what happens here with this. It's not the same. This is a ratio of 2 logs, totally different story. And this will be log of 2x plus 5 divided by x. Log is applied to this quantity. Okay, let's look at the next level, like let's say 59. In 59 we have 4. Natural log of x plus 6 minus 3 natural log x. Yes, it's a difference of 2 logs. But the difference of 2 logs requires removing the number in front of the log first. I cannot use this, the difference, if I don't, or the quotient rule, if I don't have 1 in front. If it's not 1, I cannot come up with this. Which means that I have an intermediate step to take care of, removing the 4 and removing the 3. And then x plus 6. Very good. Very good. And now I can write this. Only now. It's natural log of the top, which is x plus 6 to the 4th, over the natural log of, over x cubed, coming from negative natural log x cubed. Say it again. You can. If you want to use parentheses, you can. It doesn't matter. With or without. Same thing. Okay. So let's look at one more, unless you want more. 70 log x plus log x squared minus 4 minus log 15 minus log applied to x plus 2. Let's see how you do. 1 minute. Let's work on this. See that these two have negative in front. Their quantities must come exactly from the denominator. If you remember that, you will never make a mistake. The logs, 2 logs have positive in front. Their quantities must come from the numerator. The last 2 logs have negative in front. So their quantities must come from the denominator. And we do have one step to simplify this because the numerator factors into, very good, x plus 2, x minus 2, and 15, x plus 2, and we simplify these two. And the simplified form is x minus 2 over 15. Now, see how easy this was, since we emphasized so many times that the negative in front of a log means that its quantity, it's coming from the denominator. Otherwise, if we're not comfortable with that, then we have to factor out -1 first from these two terms before we condense. Any questions? Any questions? Would you like to work on condensing some more? Or can we look at equations? We want more condensing? Very good, awesome. So on page 501, right? Let's look at 68. One-third outside, bracket 5, natural log of x plus 6 minus natural log x minus natural log x squared minus 25, and close the bracket now. So leave the constant outside alone. We don't need to address that just yet. So this is 5 natural log of x plus 6 minus natural log x and minus natural log x squared minus 25. How many quantities will go to the denominator when we condense? 2. How many will go to the numerator? Right. However, we cannot condense the inside just yet. We have an additional step, not for this and not for that. For the first one, how do I rewrite the first one? of x plus 6 to the power of 5. Correct. Very good. Thank you, Z. Minus natural log x squared minus 25. You saw that I made your correction.
Yeah,
Are you proud of me? I didn't forget. And I added your points. I hope you looked at that, Alex.
Yes.
Okay, very good. So sorry about that. So I don't remember exactly, so I gave the 5, as you mentioned. If I don't remember, I have to assume that you are correct. Okay, so then natural log. Fraction line. What do we have at the top?
Natural log.
No, not natural log. Do not say natural log at the top, please. Yes, x plus 6 to the 5th. What do we have in the denominator? Yes? Very good. Those must come from the denominator because they have x minus in front. But now, in order for this to be complete, that 1/3 has to go away.
So we're getting all of
The cube root, exactly. Very good. Well done. So natural log, indeed, the cube root of x plus 6 to the 5th over x squared minus 25. Yes, that's what 1/3 means. The whole thing has power 1/3. And power 1/3, all it means is the cube root. Very good. Any questions for me? Is this okay? Ariel, is this okay? Any questions, please? Anything? Anyone? Any questions? I know I sound like a broken record, but if you go home and do not practice or you do not redo the problems we did in class, you do not have the foundation to do your homework. And be prepared.
So just real quick.
Yes, please.
In order to figure out what goes on top of like the fractions, however is before
If the before the log is a plus, that quantity goes to the top. If before the log is a minus, that quantity goes to the denominator. There is a more difficult way of doing this. If you don't want to remember that, you will have to factor out -1, change that into a product, and then you have a ratio. Say it again. Is that better?
well the first way to use it is better.
Okay, yeah, so that's why I'm saying there is another way, but I think this one is better. Okay. 4.4, exponential equations. Finally, we get to exponential and log equations. But first, let's work on exponential equations. I'm going to start with the simplest possible exponential equation that I can think of. Please do not simplify, do not consider that we are crossing out the 2. These are bases, we can never do that. So, here's the concept. By the way, what type of equation is it? Of course, because the variable is at the exponent level, of course. Here's how we think. 2 numbers are equal, and their bases are the same. What has to happen to their powers for the numbers to be the same? They have to x plus 1 equals 4 or x equals 3. Done. I can't think of a simpler exponential equation than this one. Of course, the next level needs work. Here's the next level. Notice in the first example, both numbers left and right of the equal symbol, they were both presented with the same base. I'm hoping that now I can present again both sides with the same base. That's my hope. Not the same base, it just happens, right? Just the same base, whatever. It can be e, it can be 55, but the same base if I can. Well, I know that 32 can be changed into 2 raised to the 2 to the 5th is 32. I put everything in parentheses to x plus 4. But now the question is, can I present the other side with base 2? Yes, 2 to each power. So 2 to a power will equal 1 over 8. Which power is that? Yes, it has to be a negative number because it's a fraction. Very good. So we're kind of close to, or back to the previous example, but not yet. What happens next? What do I do with these powers? I copy the base, and what happens with the exponents? What is the operation I need to perform with negative 3 and 2x minus 3? Say it again. No, we don't add. We add when we multiply, not we don't add when we raise to a power.
You distribute the negative 3.
Multiply, very good. We have to multiply. Negative 3 gets multiplied by 2x minus 3, and here 5 gets multiplied by x plus 4. Copy the base, multiply the exponents when we raise to a power. So now I have 2 raised to negative 6x plus 9, and I have 2 raised to 5x plus 20. After all this work, we are back to the first example. Now I can say 2 numbers are equal, and they have the same base. What has to happen to those numbers? For them to be equal indeed, what has to happen? They have to be the same. There is no other way. Because you understand, 2 to the 5th does not equal 2 to the 3rd. It's not possible. So then negative 6x plus 9 must equal 5x plus 20. I subtract 5x and I subtract 9. So negative 11x equals, look at that, positive 11. I didn't think, I just made it up. Negative 1 is the answer. Okay, this was nice. Both of them, both examples were nice. Why? Because I was able to present both sides with the same base. Well, but what if I don't? Here's an example. 2 to x minus 3 equals 7. There is no way I can present 2 and 7 with the same base. It's not possible. But then there must be a way. Say it again. Yes. Yes. So there must be a way. And here's the question I have for you first. Forget about this for a moment. When we solve the equation x plus 1, the square root of x plus 1 equals 2, what did we do? A long time ago, I know it was 2 months ago, but still. What did we do to solve this? Right. Why did I square and not take to the 3rd power? I want to take to the 3rd power. Because the 3rd power would have not cleared the square root. The 3rd power is not the inverse of the square root, but the 2nd power is the inverse of the square root. So we use the inverse function. Okay. So coming back to our problem, I want to apply a mechanism to both sides, the same mechanism like I did here, square both sides. Same mechanism that allows us to bring this power in front as a factor. And there is only one function that I can apply to both sides that will allow us to do that. There's no other function. There's only one. Which function will that be that I can apply to both sides and allows us to move x minus 3 in front as a factor? Log. It doesn't matter which one. Let's apply natural log. So in order to write the equation one more time, so wherever you want to see, this now is natural log of 2 to x minus 3 equals natural log 7. This is one of the rules, which is the power rule. But if I don't put x minus 3 in parentheses, I will only multiply natural log by -3, not by x minus 3. So when you bring that power in front, you put it in parentheses in front of natural log because the whole thing becomes a factor, not just part of it. Okay, so now this is a linear equation. I changed a complicated exponential equation into a linear one. Please do not get scared or intimidated by these two. They're just numbers. Yeah, they have a fantastic ln in front of them, but they're just simple numbers. Of course, I will divide by this and add 3. So we have x minus 3 equals natural log 7 over natural log 2. Do not write natural log of 7 over 2. Be careful. And then add 3. And this is it. And you can say, show me that this is true. Okay, if you want me to show you that this is true, I have to calculate that, approximate it, as 3 plus natural log 7 divided by natural log 2, close the parenthesis, enter, and now raise 2 to the power, in parentheses, the previous answer, and minus 3. If the answer is correct, when I press enter, what should I get? 7, indeed. If I don't get 7, the answer is wrong. The 5.807 is not correct. Exponential equations, they are kind of sophisticated. They are not trivial. So let's look at other examples. What about 22? On page 514. E raised to x plus 4 equals 1 over e to 2x. What type of equation is this? Of course, it's exponential because the variable is at the exponent level. Perfect. Good. The left-hand side, there's nothing I can do to it. I'm just going to copy it. It's e to x plus 4. But I'm hoping that the right-hand side can be presented with the same base. Which base? I'm hoping that I can present it with base e. So then, if I change 1 over e to 2x into e to what? What should the power be? It's a fraction. Negative. Very good, of course. E to negative 2x is the same with 1 over e to the x power to 2x, of course. Now I'm in business because both sides are presented with the same base. So now I'm back to saying two numbers are equal and they have the same base. What has to happen? For sure. There's no other way. X plus 4
equals to -2.
Exactly. Of course. So I move x, so I have 4 equals negative 3x, or x equals negative 4/3. The most difficult problem is number 20. Number 41. I can't think of a more difficult situation. It just looks difficult. You'll see it's not if you follow the rules. So 41. And 41 we have 5 raised to 2x plus 3 equals 3 raised to x minus 1. Well, the There is no way I can present 5 and 3 with the same base ever. And I have only one option. What is that option? Bring the powers in front. How will I bring the powers in front? Applying natural log or common log. It doesn't matter. Which one would you like to apply? Okay, log. Log is fine. So now the new equation is log 5 raised to 2x plus 3 equals log 3 raised to x minus 1. Now you have to be very careful. We are bringing down the powers. Please dictate.
Parentheses.
Yes, thank you so much. Thank you, Alex. That's what I wanted to hear. I wanted to hear parentheses. Thank you. Equals.
Parentheses.
Yes. X minus 1 natural log, common log 3. Okay. Here's what happens next. Everything is fine. Again, do not get intimidated by log5. It's a poor, simple number. Okay? We have to distribute those numbers. We have to distribute this poor number to those two terms and this poor number to those two terms. Let's do it. So 2x log 5 plus 3 log 5 equals x log 3 minus log 3. It's still a linear equation. It looks a fantastic linear equation, but it's still a poor, simple linear equation. Now, what happens is I see x in two terms. I see x here and I see x here. But I don't see x here and I don't see x here. So what should I do next? It's a linear equation. I want all terms with x on one side. And I want terms without x on the opposite side. So then I copy 2x log x, log 5, I'm sorry. And then exactly minus x log 3 equals negative 3 log 5 minus log 3. Great job. Now look on the left-hand side and say, since you cannot combine them, you must factor out what? What? No, wait, that's not possible. This is a number, nobody can separate it. This is a number, nobody can separate it. So we will factor out what? Indeed. X. Negative 3 log 5 minus log 3. Of course. That's the only common factor of the terms on the left. Just x. What is left in parentheses? Again, no x. X is out. 2 log 5 minus log 3. And finally, we're done. As long as you put at the top what? Negative 3 log 5 minus log 3, and you put at the bottom the number that multiplies x. 2 log 5 minus log 3.